We're going to go ahead and take a look at number 67 from section 9.4, simplifying and combining radical expressions. 67 reads as follows. We have the cube root of negative 54 x to the fourth, and note that all of that is underneath the radical sign. So we had mentioned previously in class that you want to take a look at the index of your radical. So in this case, I'm going to highlight that in pink. Your radical, or your index, is 3. Okay, and recall that we kind of had a prison example that we had going on here. So the 3 signified your security clearance. So in other words, in order to take a group of identical numbers out, we would need to have 3 of them in this case. So in order to see that, we're going to go ahead and flesh this out a little bit more. You won't necessarily have to do as much detail as I'm about to do, but just so you can see everything kind of work its way out. So if we have negative 54x to the fourth, I'm going to break this up into a multiplication problem of negative 1 times 54 times x to the fourth. And now what I'm going to go ahead and do is I'm going to start doing factor trees. So if you look at negative 1, do you agree that negative 1 is negative 1 times 1? And I can actually go a little bit further and say, well, positive 1 is a negative 1 times a negative 1. So that's kind of one of the big things to note with negative 1. You can actually create as many of them or as few of them as you need, depending on the index of your radical. So since the index of our radical is 3, I figured out how to get 3 negative 1s. So there they are. So I will go ahead and have my answer down here. So I know that one group of negative 1 can come out. Now I'm going to go ahead and move to the 54. And you might want to pause the video and try to break 54 down on your own. And make sure that you guys take them all the way down to their prime numbers. So go ahead and pause the video. I will obviously be right back. Okay, so if we take a look at 54, I'm going to choose 6 and 9. And then I'm going to go ahead and break that 6 down into a 2 and a 3, and that 9, into a 3 and a 3. And note here, I'm going to run x's through my 6 and my 9. I don't want to accidentally go back to them at any point, because the 9 is represented by the 2 3's beneath it, and the 6 is represented by the 2 times the 3 beneath it as well. And I'm going to go ahead and circle my prime factors here so I know that I'm going to work with them. If you notice, I have one group of 3's, so that group can break out. But unfortunately, the 2 has no one else to break out. He's all by himself. So since he doesn't have 2 other 2's to help him break out, he's got to stay in the prison. And lastly, we can go ahead and take a look at x to the fourth, which hopefully you guys agree, if I expand it out, is x times x times x times x. And again, we would know, well, here's one group of 3, so that group can come out, and one of those x's has to stay in. Okay, so your final solution, we're just going to clean this up. So if you notice, I have a negative 1 times a 3 outside. This will become negative 3x times the cube root of 2x. This is my radical in its simplified form, and I'm done.